So today we're going to finish up Chapter 10, Section 1. We'll do the last few examples, which is going to prepare you to do the Day 2 homework. So let me come here to example 5. Okay, so for this one, they're telling us that point B is a point of tangency, and they want us to find the radius of the circle. So let's go ahead and take a look. Remember yesterday we learned a theorem that told us that if a tangent, when a line is tangent or a segment is tangent to a circle, it's going to be perpendicular with the radius. So notice they've already shown us that BC and AB are perpendicular because of the right angle. And what this is formed now is a little right triangle here. So now in order to find the length of the radius, I'm going to use Pythagorean theorem. So I'm going to be doing a squared plus b squared equals c squared. I'm bringing back chapter 9. Now remember the two sides that form the right angle, that's your A and your B. Doesn't matter which one you label as A or B. I'll say this one right here where the R is going to be my A. This will be my B. And the 16 plus R is going to be my C. So this is where we're going to be foiling. So A is R, so I'm going to square it. I'm going to square the 24. And then C is going to be R plus 16. And I have to square that. Now, do not be tempted to just square the R and square the 16 and think that's your answer. What we need to do here is, the easiest way is to write this binomial twice and now either apply distributive property to it or FOIL. FOIL is just an acronym that you can use to remember what to multiply when. So if I go ahead and square the 24 first, I get 576. Now I'm going to work on these two binomials. So if I use the acronym FOIL, R times R is the first two terms, and that gives me R squared. Then when I do the outer or the outside terms, R times 16 is 16R. Or again, just think about distributing the R to both of the terms. And now I'll go to the inside term. 16 in R, again, is also 16R. And now finally, the last two terms, the 16 times 16, gives me 256. So this is the acronym FOIL. This is the last. The purple was the inside, and then the red was the outside. Or again, all you're doing is distributing. Now I need to combine my like terms. So I'm going to go ahead and combine the 16 R's here. So now this side's going to become R squared plus 32R plus 256. This side is staying the same for right now. And now I need to get my like terms together. So I'm going to work on getting the R squareds together by subtracting it. But notice when I subtract it from the left side, I'm also subtracting it from the right, and it cancels both of them out. So now I'm just left with 576 is equal to 32R plus 256. My goal is to get R by itself. So all I need to do is subtract both sides, the 256, to get the 32R by itself first, and then divide. So 576 minus 256 gives me 320. And now I'm just going to divide both sides by 32. And my radius length, or the value of R, is 10. So you're doing this in the homework. Obviously, it's a lot of work here. So when you do these problems, make sure you're showing all of this work. The next example on the next slide is exactly the same thing. We're going to plug it into Pythagorean theorem. We're going to need to FOIL or distribute, and then combine like terms. So for the next one, again, they're telling us that B is the point of tangency, and at that point of tangency, that's where the right angle is located. So again, remember the two sides that form the right angle, that's your A and your B. The C in my A squared plus b squared equals c squared is always going to be this side that's across from the right angle. So r plus 7, this is my c. Over here, this could be my b, and then the r again could be my a. Again, the a and the b could be switched up. So I'm going to do r squared plus 14 squared and set that equal to r plus 7 squared. I'm going to square the 14. 14 times 14 is 196. For the r plus 7 squared, if it helps you to write it down twice and then now distribute or FOIL it, you can do that. So this will give me r squared when I do first. Outside gives me 7r. Inside gives me 7r. And then last, 7 times 7 is 49. And then now, drop down the 196. And now what I'm going to do is combine my 7r's. So I can combine these like terms. So I get r squared plus 196 equals r squared plus 14r plus 49. I need to get my like terms together again. So I'm going to subtract r squared from both sides. Okay, the r squareds cancel. And now you're left with 196 So now I'm left with 196 is equal to 14r plus 49. Subtract 49 from both sides. And then you're left with 147 is equal to 14r. Divide both sides by 14. And r is equal to 10.5. I can say that if I add a variable there as an x, I can state that mx is going to be congruent to nx, because we learned that theorem that stated when two tangent segments intersect at the same common external point, those two tangent segments will be congruent. So in order to find the value of x, I'm going to set x squared equal to 9. Now, for this particular question, I can solve it two ways. I can either do it similar to what we did when we did Pythagorean theorem and just square root both sides, and x is going to equal, this time when we're solving this, it'll be both positive and negative 3, because when I plug it back in, negative 3 squared gives me 9. So this one works. When we were doing Pythagorean theorem and we square rooted to find the value of either a, b, or c, we never kept the negative answer because we didn't want a negative side of our triangle. But when you plug in a negative number now, if it works, you're going to keep it. Now, the other way to solve this would have been to set your equation equal to 0 by subtracting the 9. Then this becomes the difference of two perfect squares that we can factor into two binomials. This will factor into x minus 3 and x plus 3. And then we would set each one equal to 0. So x minus 3 equals 0, x plus 3 equals 0. We will add 3 to both sides on this one. So my first answer is x equals positive 3. And then this one will be x equals negative 3. So both answers satisfy this equation. It doesn't make any part of the picture negative. 3 and 4. Okay, so if I give you a question and it ends up being a factoring question, this is the process. So 3x and 4x, because when you multiply it, you get 12x squared. And then here, when you add those same two numbers, you get the 7x. And then we can go right into our binomials. It'll be x plus 3 and x plus 4. And then if it asks you to find the value of x, then you set each one of these binomials equal to 0. And then you would subtract, and x equals negative 3, x equals negative 4. Now, let's go ahead and go back to the problem. That is the last example in your notes, because it's a more challenging trinomial to solve. For this last one, we're applying that same theorem because when we have two tangent segments that intersect at the same common external point, which is A, this tells me that AB is going to be congruent to AD. So I'm going to go ahead and take 2x squared plus 2x and set it equal to 7x plus 12. So then now what I need to do is I'm going to get my like terms together. So I'm going to subtract 7x from both sides. I get 2x squared minus 5x equals 12. And then we need to move the 12 over. 2x squared minus 5x minus 12 equals 0. Now, when you learn this in Algebra 1, maybe your teacher told you to guess and test. And if your teacher taught you to guess and test, what you would be filling in is, in this spot, factors of 2, and then here, factors of negative 12, that when you FOIL this, goes back to that problem. But what's a lot easier is if you use the technique of factor by grouping. Now, once you do this multiple times next year, you're going to get to where you can do this really quickly. But at the beginning, you're probably better off factoring it by grouping. So that's what I'm going to do here. And when you factor by grouping, we need to take the first term and multiply it to the end. So this is going to give me negative 24x squared. So I'm looking for two numbers that will multiply to give me negative 24x squared. That will add to give me negative 5x. So I'll start my list of the multiples of 24, negative 24. Now, a little trick, the bigger factor will have the sign in the middle. So my factors could be 1n negative 24, 2n negative 12, 3n negative 8. And this is the combination I need because when I add them, it gives me the negative 5. So it'll be positive 3 times negative 8x, and then positive 3x times, added to negative 8x gives me the negative 5. Now, when you factor by grouping, you're going to take the middle term, and it's going to get replaced with these two numbers. You rewrite the first term, the 2x squared. Then you're going to put the negative 8x. It doesn't matter the order that you put the two factors that you just found. And then this is equal to 0. Now, what we have to do is group the terms. I'll group the first two together and then the second two. So now what I need to do is find a greatest common factor of the purple group. So my greatest common factor between 2x squared and negative 8x is going to be 2x. I'm going to divide. So I put the GCF down. I divide. And that's the answer to the division. Then for the red group, my greatest common factor between 3x and 12 is going to be 3. So I'll put a plus 3 here, my GCF, and then I'm going to divide. Now that I've factored it, when you do this factor by grouping, these two answers that you got after you divided need to be the same. If they're not the same, then you've done something wrong or it cannot be factored. So I write down the x minus 4, which is now in common, and then I take these two GCFs that I just divided by, and then they create my second binomial. And now I'm going to set each one of the binomials equal to 0. So x minus 4 equals 0. 2x plus 3 equals 0. I'm going to go ahead and add 4 to both sides. X equals positive 4. Subtract the 3. 2x equals -3, divide by 2, and x equals -3/2. So my two answers are x equals 4 and -3/2. Now I'll show you that when you plug them in, you would think the negative doesn't work, but it does. So remember, the two segments in my picture were 2x squared plus 2x. So if I plug in the 4, 2 times 4 squared plus 2 times 4, this gives me 2 times 16 plus 8. 32 plus 8 gives me 40. And then the other tangent had 7x minus 12. So 7 times 4 minus 12, or it's plus 12, and then 28 plus 12, and I get 40. So far so good. Now, let's plug in the -3/2. So same thing, the 7x plus 12, so 7 times -3/2 plus 12, and then also plug it into the 2x squared plus 2x. Okay, so for this one, I could add a 1 underneath. This gives me -21/2 plus 12. When I divide this, this is -10.5. And -10.5 plus 12 is positive 1.5. Over here, I got to do the exponent first. I could add a 1 here. -6/2. This gives me 18/4 plus -3. And then now what I get here, this is, if I divide this, actually I could simplify this to 9/2, which is 4.5. And 4.5 plus -3 is 1.5. And they're equal. So both answers are good answers. Even though you may think, I got a negative, it doesn't make sense, but it does.